Hi, my name is Lisette De Leon. I'm in Mr.Fies 6 p.m. class, and today we're going to solve this situation. So it says, just before 6 p.m., students enter the classroom to find Mr.Fies dead of an apparent homicide. At 6, the temperature of the body is 80 degrees, while at 7, it was 75. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? Alright, so for this problem, we're going to be using Newton's law. So the final temperature that was given was 75 degrees Fahrenheit. For the constant rate, or the time ambient, it would be 70 degrees, because right here, it reads 70 degrees. Okay, and the time of object, the time that he was found at 6 p.m. was 80 degrees. And for our K, our constant decay, we have no idea what this one is. And for time, 6 to 7 p.m. is around an hour. So now we're just going to plug it in into this formula and solve the equation. Okay, so it would be 75 equals 70 parentheses 80 minus 70, which e to the negative k 1 hour. Okay, so now that we have that, we're gonna start with the parentheses. So this becomes a 10. We're gonna subtract 70 from both sides, which that becomes a 5. Okay, so it would be, it's gonna read 5, 10, e negative k 1. Alright, so we're gonna have to put 10 to the other side. So what we're gonna do is divide 10 from both sides. Alright, so now we have that, we should get 1/2 equals e to the negative k1. Okay, so now that we have that, we have to eliminate e. And in order to eliminate e, we have to use the inverse, which is ln, or natural log. So ln on both sides. Alright, so after we have that, we're going to cancel that out, plug this in the calculator, and the answer that we should be getting is k equals negative 0.69314718. And that is your constant k. Alright. So for the next problem, we're going to be determining and discuss the appropriate time elapsed to the nearest 10 from the time of death to the time of discovery. Okay, so again, the final result for that would be 80. So we're going to plug that in. 80 equals our time ambient, which is 70. Our time object, I put 98.6 because that's the average. That's like you're alive. Whenever you're alive, your body temperature is around 98.6. So 98.6 minus time ambient, which is 70. E to the negative 0.69314718, and then t. Okay, so now that we have that, we're going to be going to subtract. So I'm going to do the easy part first. 70 in the case, it's going to equal 10, and then 98.6 minus 70, which should give us 28.6, but let's just make sure. 6, 8, 7, 8, 9, 28.6, yeah, 28.6. Okay, so after 28.6, e to the negative 693147181 t. Okay, So now we're going to divide both sides by 28.6, both sides. Alright, and now we're going to have to find the natural log to cancel the e out. The natural log and the natural log is going to be equal to ln 10 to the 28.6 equals negative 6.6931478 t. Okay, so after we have that, we have to move this to the other side. So what we're going to do is put 1 over negative 0.693147781, just like that. Okay, now we're going to multiply this together, and the answer that we should be getting is 1. To be exact, 1.51601514. And that's your time. Oh, wait, after this, sorry. After this is your time, but since you're trying to figure out the time to determine C, so now you have 1.52. Okay, so you know you have 1 hour in, now you have 52 minutes, but that's not 52 minutes. So what we have to do is divide 52 divided by 100 equals 60. So what I did, I just cross multiply, and the number that I got here was 320, and then I divided by 100, and I got 31.2. 31.2. So I think I'm just going to round it to 32 minutes. Okay. So from 6 p.m. to 5, it would be 5 p.m. And then now we're just going to subtract. So 5 p.m. minus 32 it would be 4:28 p.m. and that is the time of death.